Hey everyone! Today we're diving into how to integrate MCP servers using the OpenAI Agents SDK, and we'll also go ahead and build our own custom server from scratch. If you've got any ideas or cool use cases in mind, drop them in the comments and let's collaborate. Alright, so first off, let's check out our databases. The first one spun up in Supabase and is basically just a list of clients. The next database is set up in Notion and it holds a list of orders. Each row in that database has a customer ID that matches the one in the Supabase client database. Alright, so before we jump into building the agents, let's go over what environment variables we'll need. OpenAI API key. Your API key, this one's required to interact with the AI models. OpenAI model, the name of the OpenAI model you're using, like GPT 4.1 for instance. Supabase PAT, your personal access token for Supabase, used for authentication. Notion token, the integration token for the Notion API. Supabase project ID, the unique project ID for your Supabase setup. First thing, we'll import our environment variables. After that, we'll set up our first MCP server and pass in the Supabase PAT so it can authenticate properly. We'll also spin up a second MCP server for Notion and pass in the integration token there so it can access the necessary databases. Next up, we'll add two function tools so the agent can get the Supabase project ID and the Notion database ID directly from the context when needed. Now let's write the system prompt where we'll specify which data sources the agent should use. In practice, it turns out that explicitly stating the purpose of each database helps reduce errors quite a bit. Next, we'll create our agent and hook it up with the function tools and both MCP servers. That way, it'll be fully wired to interact with Supabase and Notion as needed. Now, let's put together a simple chat simulator. It'll support back-and-forth dialogue, which gives us console for iterative command input. Inside this chat setup, we'll also make sure to tell the agent to use our context to fetch any necessary identifiers so everything stays dynamic and in sync. And once we've got our agent up and running, we'll go ahead and send in a request asking it to show us the list of orders. As a result, we're seeing a unified table that pulls together data from two separate databases across different apps. The matching was done via customer ID, which is pretty awesome, and the best part? We didn't make a single API call to get that result. Now let's take it a step further. We'll ask the agent to update the address of one of the clients, and then check if that change actually reflects in the Supabase database. Let's go ahead and open our database and refresh the page. Perfect. The address has been updated from France to the US. So yeah, this shows that we're not just able to fetch data through the agent, but we can also update it seamlessly. Now let's take a look under the hood at how this works in the logs. What we see is that every time we send a message to the agent, it receives a list of available commands and makes a decision on which one to call to fetch the right data and return an accurate result. Now, let's create our own custom MCP server. I've got a fork of the public Pokémon API, and using Postman tools, we can generate an MCP server from the collection ID. Once it's generated, the server will expose a set of commands automatically based on the API endpoints. After downloading the ready-to-go MCP server repo, we can open it up and see exactly which commands were generated for us. Awesome! Let's quickly spin up a second agent that uses our MCP server built on top of the Pokémon API. For this one, we'll point it to the local path where the server description lives. Once it's up and running, we'll fire off a request asking it to fetch info about Pikachu, and let's see what it comes back with. And yep, we got a response. Then we asked for info from the Pokédex, but this time, there was an error on the API side. The agent let us know about the issue, but since it still had some built-in knowledge, it went ahead and gave us the info anyway. So even when the external API stumbles, the agent's fallback on its own context makes sure we still get something useful. Pretty neat. Now let's check the logs to see what commands the agent has access to. One that stands out is the command to fetch an evolution chain. So let's take that as our example. We'll go back to the agent's console and ask it to show us the evolution chain for a specific Pokémon. Once the request runs, we get a valid response with no errors. Everything works as expected. This really shows the flexibility and power of the MCP setup, where we can take any existing API, even something as niche as a Pokémon API, and in just a few steps, wrap it into an MCP server. From there, it becomes fully accessible to the agent, letting us query it, extract structured data, and even combine it with other tools, and all with minimal manual setup. It's a super efficient way to bridge traditional APIs with modern AI-driven workflows.